Deformation and fracture mechanics are two key concepts in engineering that are essential in understanding the behavior of materials under stress and their failure mechanisms. Deformation refers to the change in shape or size of a material when subjected to an external force, while fracture is the breaking of a material due to the same external force. In this essay, we will discuss deformation and fracture mechanics and their applications in engineering. Deformation mechanics. Deformation mechanics is concerned with the study of how materials behave when subjected to external forces or loads. Materials may experience elastic or plastic deformation, depending on their mechanical properties and the intensity of the applied force. Elastic deformation is temporary and reversible. Materials return to their original shape after the force is removed. In contrast, plastic deformation is permanent, and the material's shape changes even after the force is removed. Stress and strain are two critical parameters in deformation mechanics. Stress is defined as the force per unit area applied to a material, while strain is the ratio of the change in length or volume of a material to its original length or volume. The relationship between stress and strain is captured in a stress-strain curve, which shows how materials behave when subjected to stress. Fracture mechanics. Fracture mechanics is concerned with the study of how materials behave when subjected to forces that cause them to fracture. The study of fracture mechanics involves understanding the origin, propagation, and eventual failure of a material under external loads. A material's ability to withstand fractures is critical in ensuring the safety and reliability of structures. One of the most important concepts in fracture mechanics is the fracture toughness of a material. Fracture toughness is the ability of a material to resist crack propagation when subjected to external forces. It is determined by measuring the critical stress intensity factor, which is the measure of the stress required to propagate a crack in a material. Applications of deformation and fracture mechanics in engineering. The understanding of deformation and fracture mechanics has numerous applications in engineering. These applications include the design and construction of bridges, buildings, aircraft, and other structures that require high strength and durability. For example, in the design of aircraft, deformation and fracture mechanics are critical in determining the structural integrity of the aircraft under different loading conditions. Knowledge of deformation and fracture mechanics is also critical in the design of materials for use in prosthetic devices, medical implants, and other medical applications. In addition, deformation and fracture mechanics are critical in the oil and gas industry. The oil and gas industry relies on materials that are capable of withstanding high pressure and high temperatures. Understanding how these materials behave under such conditions is essential in ensuring their reliability and safety. Conclusion. In conclusion, deformation and fracture mechanics are two key concepts in engineering that are essential in understanding the behavior of materials under stress and their failure mechanisms. A thorough understanding of these concepts is critical in the design and construction of safe, reliable, and durable structures. Deformation and fracture mechanics have numerous applications in various industries, and their importance is only set to grow as engineering continues to advance.